So this is the last part of section 1.1. It should be shorter. I know I kind of ramble on sometimes, so I'll try to not make it that long. So two definitions before we get to the problem. Two definitions, some examples, and then we'll get to some homework problems. First definition, what does it mean for two sets to be equal? Two sets are equal if they have exactly the same elements. So example, are sets A and B equal? A has the elements A, B, C, D, and E. B has the elements E, D, C, A, and B, which is really A, B, C, D, and E. Are those equal? Yes, those are certainly equal because they both have exactly the elements A, B, C, D, and E, even though set B is written in a different order than set A. Yes, these are considered equal sets because they have exactly the same elements. Example, are sets A and B equal, where A has the numbers 1, 2, and 3, and B has the letters A, B, and C. Well, 1, 2, and 3 are not exactly the same as A, B, and C, so those can't be equal sets. So the answer would be no, since they don't have exactly the same elements. Although they have the same number of elements, and that's going to be the next concept we get into. When sets have the same number of elements, there's a word that we use to describe that. Example, are sets A, B, and B equal, where A is the set containing the numbers 1, 2, and 3, B is the set containing the 1, 2, 3, and 4, A has 3 elements, B has 4 elements. They can't be equal. We'll say no, A doesn't have these. So the answer is, are these equal? No, because A doesn't have a 4, which B doesn't, so they're not equal. So to be equal, you have exactly 100% the same element. If there's any difference between the two sets, then they're not equal. Here, they're completely unlike each other, so they're not equal. And here, B has that extra 4 that A doesn't have, so they're not equal. To be equal, you need exactly the same elements, not necessarily written in exactly the same order. The next concept kind of confuses students. It's the concept of equivalence. And two finite sets are equivalent if they have the same number of elements. That is, two sets are equivalent if the number of elements in set A equals the number of elements in set B. So two sets are equivalent if they have the same number of elements. Are these two sets equivalent? The same sets A and B. Well, the number of elements in set A is 5, and the number of elements in set B is 5. They're equal, yes, but that's not the question. It says, are they equivalent? They are equivalent because they both have 5 elements. So even though they're equal, that's not what's being asked here. It's a simple yes, they're equivalent, or no, they're not equivalent. To be equivalent, you have to have the same number of elements. How about the same sets that we looked at for the equal question? Are these sets equivalent? Well, A has the numbers 1, 2, and 3, so the number of elements in set A is 3. B has the letters A, B, and C. The number of elements in set B is 3. Because they both have the same number of elements, even though they're not the same elements, these are equivalent sets. So yes, they have exactly the same number of elements. That's all it takes to be equivalent. So these two sets right here, these sets A and B, they're both equal because they have exactly the same elements, and they're equivalent because they have the same number of elements. These two sets down here, they're equal, they're equivalent. Can I save that? They're equivalent because they both have 3 elements, but they're not equal because the elements are different. So these are different concepts. Equal means you have exactly the same elements. It's a lot harder to be equal than it is to be equivalent. As a matter of fact, if you're equal, you're going to be equivalent. But you can be equivalent and not be equal. Here's two sets that are equivalent because they both have 3 elements, but they have different elements, so they're not equal. These two sets are equal because they have exactly the same elements. They're equivalent because they both have 5 elements. And the other example that we did, are these two sets equivalent? Well, to be equivalent, they have to have the same number of elements. The number of elements in set A is 3. The number of elements in set B is 4. Are they equivalent? No, because they have a different number of elements. To be equivalent, you have to have the same number of elements. It doesn't necessarily have to be the exact same elements. This is where we get to the confusion. Determine whether the sets are equal, equivalent, or neither. So the first thing I'm going to do is I'm going to decide, are sets A and B, are they equal for these two sets? Well, to be equal, they have to have the same elements exactly, and they don't, because in order for B to be equal to A, it'd have to have the same letters of A, so it's going to be no. But they still could be equivalent. Are they equivalent? A has 4 elements. B has 4 elements. Since they both have 4 elements, they're equivalent. So these two sets, they're not equal, but they are equivalent. So I'm supposed to determine whether the sets are equal, equivalent, or neither. These can't be neither, must be they're just equivalent. So my answer to this problem right here is that these two sets are only equivalent. They're not equal because they don't have exactly the same elements. They're equivalent because they have the same number of elements for each. Let's look at another couple sets. Determine whether these sets are equal or equivalent or neither. Let me first figure out whether they're equal or not. To be equal, they have to have exactly the same elements. They both have A, they both have B, they both have C, both have B, and they both have D. They're equal because they both sets have the letters A, B, C, and D. So yes, these are equal sets. Now, are they equivalent set? Well, to be equivalent, the number of elements in set A has to be the same as the number of elements in set B. The number of elements in set A is 4. The number of elements in set B is 4. So these are also equivalent. They're equal because they have exactly the same elements. They're equivalent because they both have 4 elements. The answer to this, these sets are both equal and equivalent. Determine whether the sets are equal, equivalent, or neither. A has B, C, D. B has A, C, D, B. A doesn't have this A, so they're not equal. The reason they're not equal is because this set has an A that that set doesn't have. And they're not equivalent either. Why are they not equivalent? It's because the number of elements in set A is 3, and the number of elements in set B is 4. They don't have the same number of elements, so they're not equal, they're not equivalent, and we're supposed to determine whether they're equal, equivalent, or neither. Because they're not equal and they're not equivalent, they're neither equivalent nor equal. So the answer to this is going to be they're neither. Now we're ready to do some of the homework. The instructions for the end of the section says just determine whether the sets are equal, equivalent, or neither. And I'll just write down those words. So for my set in 36, they're not equal because B doesn't have a 1 that A has. They're not equivalent because the number of elements, so they're not equal. They're clearly not equal because this set is missing their 1. And they're also not equivalent because the number of elements in set A is 4 and the number of elements in set B is 3. To be equivalent, they have to have the same number of elements, and so they're not equivalent. So my answer to 36, are they equal, equivalent, or neither? I'm going to write neither for my answer. That's going to be a lot different than your 35. So take a minute to do 35, and your answer should be equal because they both have A, B, C, and D, and equivalent because they both have 4 elements. We'll work through 37 and 38. Your 37, heck, let me just do 37 with you. Why don't you pause the video and do 37 if you don't know the answer. For 37, they're clearly not equal. The reason they're not equal is because this set is missing that C. And in order for them to be equivalent, the number of elements in set A, which is 2, would have to equal the number of elements in set B, which is 3. They're not equal because the first set is missing the C. They're not equivalent because one set has 2 elements, the other set has 3 elements. Your answer to number 37, or this is going to be a big old neither. So for my problem 40, these are clearly not equal because they don't have exactly the same elements. Lemon, cherry, and apple aren't the same as 1, 3, and 2. But in terms of equivalent, the number of elements in set A is 3, and the number of elements in set B is 3, so they're equivalent. So they're not equal, but they are equivalent. My answer to problem 40, these things are only equivalent. That's going to be your answer to 39 as well. For 39, it's going to be only equivalent. So if you can stumble through 41, I'll scribble an answer down. For my 42, they're clearly not equal. They're not even close. So they're clearly not equal because they don't have exactly the same elements. And for my 42, the number of elements in set A is 3. The number of elements in set B is 4. They don't have the same number of elements, which makes them not equivalent. So my answer for 42, this is going to be one of those neither. It's either equal, equivalent, or neither. And your answer for 41, they're not equal because they don't have exactly the same elements, but they do both have 2 elements. So these are going to be equivalent sets. Oh, just a few more problems to do. For my problem 44, these sets are clearly equal because they both have the numbers 1, 2, 3, 4, and 5. So part of my answer to 44 is going to be equal. And because the number of elements in set A is 5 and the number of elements in set B is 5, they're also equivalent. So my 44 is going to be both equal and equivalent. For your 43, I think I have the answer right here. Your 43 is going to be neither, and for your 45 is going to be equal and equivalent. That's the end of the section. I just really wanted to put this, it's only 13 minutes, in its own section just to force you to look at it kind of maybe with fresh eyes, because I put this on the test every semester and a lot of students miss it, and it's not that hard. So it must have been that I just threw it at the end of a 1 hour long video and students just burned out. So hopefully you got these problems down. Don't move on to section 1.2 until you feel good with section 1.1. And, well, let me just stop this video and we'll move on to section 1.2 whenever we get to it.